Okay, guys, so today's assignment is VT graph number 2. Similar to the homework yesterday, you're going to be asked to solve for the distance the object has traveled and be asked to solve for the acceleration. So in the very first problem, all right, so problems 1 and 2 go with the graph on the left. Problems 3 and 4 go with the graph on the right. So what we got here is this is a mouse pointer. Oh, nice. Oh, dang it. Is there a way I can just use a pointer? What? All right, sorry. So this guy's here, our first graph. When it asks you to find the distance from 0 to 4 seconds. So we go to 0. What is our initial velocity? So basically, where are we at 0? That's your VI. You're at 0. Okay, where are you at 4 seconds? Go to 4 and go up and then across. You're at 60. Okay, so you have 60 meters per second worth of your velocity there. And how long were you moving for? Well, 0 to 4 seconds, guys, is 4 seconds. So the distance equation is add the two velocities together, multiply by the time, and then divide by 2. So the first one, you should get a distance of 120 meters. Now you need to pay attention because on the y-axis for this graph on the left, you're increasing by 5s, which comes into play in the next problem. Okay, then they ask you for the distance for 4 to 10 seconds. So at 4 seconds, you go up and across, we're still at 60 meters per second. And then at 10 seconds, we go up and go across. Now, some people like to say that that's 80, but again, this guy right here is 70. So the next one up will be 75 because, again, this is going up by 5s. So we have 60, 75, and then we moved for a total of, from 4 to 10 seconds, is 6 seconds. Add the two velocities together, VI plus VT. I'm sorry, VI plus VF. Multiply by time, and then divide by 2, and you should get a distance of 405 meters there. So you have to do the last distance. I'm going to just show you the first acceleration problem for this graph. So the acceleration for this graph, 0 to 4 seconds. Well, guess what? What's awesome is since you already found VI, VF, and T for the 0 to 4 seconds, those are the same for the 0 to 4 seconds for the acceleration. It's just the equation is a little different. The equation is VF minus VI divided by the time. Okay, remember that a negative slope is going to wind up giving us a negative acceleration. So you got to make sure that you're doing VF minus VI. All right, so in this case, we have a final velocity of 60. The initial is 0, so 60 minus 0 is 60. Divided by 4 is going to give us 15 meters per second squared. Meters per second squared, guys, is the unit for acceleration. And if you forget how to do the exponent on a Google Doc, you type in meters per second m/s, and then you would hit Control period, and that will jump your cursor up so you can put on your exponent. Let's do the 4 to 10 second guy. Oh, crazy. That's great. We still have that same piece of information. Okay, we still have an initial velocity of 60, a final velocity of 75, and a time of 6 seconds. So for this one, the acceleration, the equation is VF minus VI divided by T. So we got to do 75 minus 60 divided by our time, which is 6 seconds. So 75 minus 60, All right, we're getting 15 divided by 6. And so we're coming out with an acceleration of 2.5 meters per second. And how do I get the squared again? Control period. And then you can see it jumps up. And then I can hit my 2. And if you want to get out of it, then you just hit control period again. And then I'm just going to highlight that work here. So it's a nice boom, yellow pops out for us. And there's 2 down here at the bottom. So let's just finish the first graph. So you have something to base off and work from. So at 10 to 14 seconds, what, guys, is my initial velocity at 10 seconds? Well, basically, what is my speed at 10 seconds? So I go to 10, and I go up and across. I'm at 75. So VI is going to be 75 meters per second. My VF is going to equal, what is my final velocity? Well, what is my velocity at 14 seconds? So go to 14, boom, right there. All right. So guys, yeah, it shifts over a little bit, right? So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 14 is where it ends. So what is my velocity there? It's 0. And then how long was I moving for here? The 14 seconds is how many seconds? 4. So the equation for distance is, you add the 2 together, 75 plus 0 times by the time, which is 4 seconds, and then you're going to divide by 2. And that is going to equal 75 times 4, 300 divided by 2, we got 150 meters as our distance traveled there. And so the last problem for acceleration, this 10 to 14 seconds guy, we're going to have the same numbers there, the same VI, same VF, and the same time. Okay, so we're doing the 10 to 14 seconds. So let me copy that, Control C. And so from this 10 to 14 seconds, Control V. Okay, acceleration, the equation is VF minus VI. Well, there we go. Add this down again. There we go. I was wondering why that looked a little sloposaurus there. Okay, so the acceleration is VF minus VI. So VF was 0, minus VI, which was 75, and then divided by the time, which was 4. So 0 minus 75 is negative 75, and negative 75 divided by 4 is going to equal a negative 18.75 meters per second squared. And again, how do I do the squared? Control period squared. Just type in the 2 there. I'm just going to make this right here. Get rid of that guy. Copy this piece. So, to get like the acceleration stuff here, guys, you may need to like hit the tab button a couple times. Get your VI and VF underneath where it needs to go. So you guys are going to complete the graph to the right. So you have a whole set of information to look at. You have a whole thing to look at to base your answers off of. All right, I'm going to just kind of go over those real quick. So these are what you should have for number 1. These should be your answers here. So make sure you guys copy those down. And then for number 2, we have these 3 accelerations. You should have, for the 0 to 4 seconds, you should have 15 meters per second squared positive. For the 4 to 10 second range, you should have a 2.5 meters per second squared. And then for the 10 to 14 second range, it should be a negative 18.75 meters per second squared. All right, so you guys are going to basically use that as an example to complete the graph on the right-hand side.